Imagine walking into a nursery and finding a group of toddlers who are 6 feet tall, weigh 200 pounds, and are solving advanced calculus. That is the level of shock astronomers are facing right now as they peer through the golden eye of the James Webb Space Telescope. For decades, we had a very comfortable and orderly narrative for how our universe began. It was called the Lambda CDM model, our standard model of cosmology. The story went like this. 13.8 billion years ago, the Big Bang happened. The universe was a hot, dense soup of particles that slowly cooled down over millions of years. In this version of history, gravity was a patient architect. It took a long time, hundreds of millions of years, for the first gas clouds to collapse into tiny, dim stars. These stars then slowly gathered into small, messy proto-galaxies. We believed that massive, majestic galaxies like our own Milky Way were late bloomers, only reaching their full size after billions of years of mergers. It was an elegant, logical picture. But then we turned on the lights. To understand why Webb is so revolutionary, we have to remember that looking into deep space is literally looking back in time. Because light has a finite speed, the light arriving from a distant galaxy today actually left that galaxy billions of years ago. For years, the Hubble Space Telescope was our premier time machine. But Hubble had a limit. As the universe expands, it stretches the light traveling through it, a process called redshift. For the most ancient objects, their light has been stretched so much that it moved out of the visible spectrum and into the infrared. Hubble couldn't see it. But the James Webb Space Telescope, or JWST, was built specifically for this. With its 6.5-meter golden mirror and cryogenically cooled sensors, it can see that hidden ancient light. And the moment it opened its eye, the orderly story of our cosmic infancy didn't just change, it shattered.
Almost immediately, Webb started finding things that shouldn't exist. Scientists have nicknamed them red monsters. These are galaxies from the first billion years after the Big Bang that are already nearly as massive as our Milky Way. According to our best physics models, there simply wasn't enough time for gravity to gather that much matter into such a compact space so quickly. It's like finding a fully functional skyscraper in a city that was founded only yesterday. One specific galaxy, Jade's GS Z14-0, was seen just 280 million years after the Big Bang. Not only is it incredibly bright, but it contains carbon. Why is carbon a big deal? Because carbon isn't made in the Big Bang. It's forged deep inside the hearts of stars. For carbon to be there so early, it means an entire generation of stars must have already lived, died, and exploded before this galaxy even formed. The universe didn't just crawl into existence, it sprinted. Scattered across Webb's deep field images are mysterious, compact objects known as little red dots. These have sparked a fierce debate among astrophysicists. Some believe they are early-stage supermassive black holes, growing at a rate that defies our current understanding of how black holes feed. Others propose a more radical theory. They might be a brand new type of supermassive star, 1,000,000 times the mass of our Sun, that lived fast and died young. Whatever they are rule breakers. They suggest that the early universe was far more chaotic and productive than we ever dared to imagine. Perhaps the most profound discovery isn't just about galaxies, but about the fabric of space itself. There is a nagging problem in science called the Hubble tension. When we measure how fast the universe is expanding today using nearby stars, we get one number. But when we calculate the expansion rate based on the afterglow of the Big Bang, we get a slower number.
Many scientists hoped Webb would show that the discrepancy was just a measurement error. Instead, Webb's precision confirmed that both measurements are correct. This tells us the problem isn't our telescopes. The problem is our understanding of the universe. It suggests there is a missing chapter in our laws of physics, perhaps a new form of dark energy or a feature of gravity we haven't discovered yet. So, does this mean the Big Bang is wrong? No, the evidence for a hot, dense beginning remains overwhelming. But it means our standard model is incomplete. It's like having a map of a forest and realizing the forest is twice as big and full of trees you've never seen before. The James Webb Space Telescope hasn't just given us answers, it has humbled us. It has shown us that the cosmic dawn wasn't a quiet, gradual sunrise. It was a riot of brilliant creation, filled with giants and monsters that appeared almost overnight. We used to think we knew the scale of the universe, but Webb has revealed the true scale of our own cosmic ignorance. And in science, that is the most exciting place to be. We went looking for the very first light of creation, only to find that the universe was already waiting for us, far older, far bolder, and far more mysterious than we ever had the courage to imagine.